We have spent 2 days on Prometheus theory, metrics types, PromQL queries, how scraping works. Today we build a real monitoring stack from scratch. Not just getting Prometheus running, anyone can pull a Docker image. We want a setup with metric filtering, custom app instrumentation, and alerting rules that will not spam your on-call team at 3 a.m. By the end of this video, you will have a 4-container stack that mirrors how production monitoring actually works. Let us start with the Docker Compose file. We need 4 services. Prometheus itself for scraping and storing metrics. Node Exporter for host-level metrics like CPU, memory, and disk. Our application, which we will instrument with custom metrics. And Alertmanager for routing alerts to Slack or PagerDuty. The key flags on the Prometheus container are storage retention set to 15 days and web enable lifecycle. The retention keeps disk usage predictable. Prometheus stores roughly 1 to 2 bytes per sample, so 10,000 times series scraped every 15 seconds generates about 1 gigabyte per day. 15 days is plenty for operational dashboards. For anything longer, ship metrics to Thanos or Cortex. The lifecycle flag lets you reload the config with a post request to the reload endpoint, which means you can push config changes through CI without restarting the container. Now the Prometheus configuration file. The global section sets scrape interval to 15 seconds, which is the standard default. Scraping more frequently burns storage without adding much value for most use cases. The scrape configs section defines 3 jobs. First, Prometheus monitors itself. This gives you metametrics like scrape duration and target health. Second, Node Exporter on port 9100. Third, our application on port 5000. Here is the important part on the Node Exporter job, the metric relabel configs block. Node Exporter exposes hundreds of metric families. Cooling metrics, hardware monitor, NFS stats. If you are not using NFS, those are just noise. We add a drop action with a regex matching the metric families we do not need. This runs after the scrape but before storage, so Prometheus fetches everything but only keeps what matches, 230 to 330. Let us instrument our application. I have a Python Flask app with 4 metrics. A counter for total HTTP requests with labels for method, endpoint, and status code. A histogram for request latency. A gauge for in-progress requests. And another gauge for a business metric, the work queue depth. The histogram is where people make the most mistakes. The default buckets in the Prometheus client library go up to 10 seconds. But if your API responds in 50 to 200 milliseconds, most of those buckets sit empty. Empty buckets waste storage and make percentile calculations less accurate because the interpolation has to bridge large gaps. I set my buckets to match actual latency, starting at 10 milliseconds up to 2.5 seconds. The label choices on the counter matter just as much. I have 3 labels: method, endpoint, and status. Each unique combination of label values creates a separate time series, 330 to 430, with metrics flowing. We set up alert rules. The first rule fires when the 5-minute error rate exceeds 5% for 2 consecutive minutes. That for clause is critical. Without it, a single spike in errors triggers the alert. 2 minutes ensures we only fire on sustained problems. The second alert uses predict linear, one of my favorite PromQL functions. Instead of alerting when disk usage hits 90%, which might be fine on a 10 terabyte volume, it extrapolates the current fill rate and alerts when the disk will hit 0 within 4 hours. This catches slow leaks that a fixed threshold would miss entirely. For the Alertmanager routing, we group alerts by alert name and job. This means if 50 instances of the same service all start erroring simultaneously, you get one notification listing all 50 instances, not 50 separate pages. 430 to 515, let us bring up the Stack and verify everything works. Docker compose up -d, then hit the application a few times to generate traffic. Use curl to query the Prometheus targets API and check that all 3 jobs show health status up. Then check the rules API to verify your recording and alert rules loaded correctly. Finally, hit the tsdb status endpoint. This tells you the total number of active time series. Bookmark this number. If it suddenly jumps by 10x after a deployment, someone introduced a high cardinality label and you need to find it before Prometheus runs out of memory. Quick recap. Pin your container image versions because latest is not a monitoring strategy. Set retention time and size limits to keep disk usage predictable. Drop metrics you do not need at ingest time. Customize histogram buckets to match your actual latency distribution. Control label cardinality like your uptime depends on it, because it does. And set for durations on every alert rule so you are not training your team to ignore pages. Tomorrow we connect Grafana to this Prometheus instance and build dashboards that are actually useful during incidents. If you are following along with the 60-day production engineering challenge, drop a comment with your setup. See you in day 8.